Right, so I started the recording, just FYI, and welcome also from my side. So my name is Markus Meyer. I used to be an assistant professor at Maastricht University, but recently switched to the European Trade Union Institute, and now I'm a senior researcher there. But during my time at Maastricht University, together with the rest of the team, we developed this well, the ancestor project, as Cody called it, it's still ongoing, the CVCM project, and I will tell you a few minutes about that project. Now, Cody, if you could go one further. So the cross-border company mobility project, which I often refer to as a CVCM project as shorthand, it concerned a project that was by the ETUI back in 2015 already commissioned to collect cases with regard to the question where and how cross-border company mobility is taking place. And by collecting cases, I mean every single transaction that within the European Union is taking place between two countries for that cross-border element to be fulfilled, we have collected. We have been doing this since 2015 for a number of countries and since 2017 for the entire EU. And it's an ongoing data collection that Thomas Biermeier, the picture that you can see there on the left, together with me, as well as student assistants, and then also with colleagues from the Institute of Data Science. So Pedro, as well as Cody, of course, are in the audience today, but also Sean and Ramsey helped develop the data pipeline for this. We collect data for, at this point already, the years 2000 to 2021, but most of the cases, so it's only a handful of cases, most of the cases concern the time spent 2006 to 2021. And we collect all cross-border mergers, divisions, and conversions between those EU countries. And that's the base data set that has been the basis for this project as well. And yeah, I'm very happy that we could build upon this in this project, and Cody will tell you more about that from here on. Back to you, Cody.
Thank you, Marcus. So as Marcus indicated there, his colleagues and student assistants have been collecting this data over a long period of time. And what we noticed when the Institute of Data Science got involved in the project is that we spotted some challenges that they were experiencing in the collection of this data, and in terms of the efficiency in which it was collected, and also dealing with various data quality and data inconsistency issues that they needed to resolve. And my colleagues and I from the Institute of Data Science tried to help solve these issues. Then we had this idea to connect and construct this knowledge graph based on this information, where we represent the data in terms of a graph with entities and relations, connecting multiple different sources for the data, because the data comes from various scattered data sources, and they're available in different formats, in different files, and so on. And the knowledge graph provides a way to harmonize and integrate all this information together and present it in a structured way that makes it easier for machines and humans to understand and analyze. So this is kind of the main goal of the project, is to construct this graph and to construct also technical infrastructure, research tools to help us analyze and work with this graph, and potentially helping us to also connect this graph with other similar graphs which are collecting similar kinds of information. And that helps us to get more insights into this data. This project is also in collaboration critically with the European Trade Union Institute, who is kindly helping fund the collection of this data, as well as our societal partner RiskSearch Technologies, who is a startup company in financial risk. And they are originally from the Brightland Smart Services campus. So the project team, just to quickly introduce you to everyone, myself, Cody Moodley, as I mentioned earlier, assistant professor in data science at the Institute of Data Science and the Faculty of Law at Maastricht University. We also have a data engineer on the team, Pedro Hernandez, who is also now a data steward at Maastricht University. And then Marcus Meyer, who is the project leader of the Cross-Border Company Mobility Project, and an EU company law expert, and he's now a senior researcher at the European Trade Union Institute. Ruta Lepina is a legal annotation expert. She's an assistant professor in private law at the Faculty of Law at Maastricht University. We also have developers and research assistants on the project. Alex Altino, who's from Research Technologies, is a software engineer, and Christiana Philippe, who is a front-end developer from Research as well. We have Walter Simoncini and Tobias Breuer, who are student assistants from the Department of Data Science and Knowledge Engineering, as well as the School of Business and Economics. And finally, our partners, European Trade Union Institute and Research Technologies. The ETUI is represented here by Alina Hoffman, who's our contact point from the ETUI, and Diana Mitroy, who's our contact point from Research Technologies. Okay, so now I will hand over to my colleague Ruta Lepina, who will explain a little bit more about the data collection and data gathering process in the project.
Okay, thank you, Cody. I'll just share my screen as well. Okay, can you see the screen? Great. All right. Welcome, everyone. My name is Ruta Lepina. As Cody already introduced me, I'm an assistant professor in digital legal studies at Maastricht University. And in the next 20-25 minutes, I'm going to talk about the process of gathering company data and the tools and outputs that we developed in the NWA project. Before I jump into the data collection, I just wanted to map out the different areas that we tackled in this project. So we started with data collection, and as Cody said, we looked at the old practices and we tried to look for new ways to make them more efficient or more accurate, or to simply make it simpler for also all the parties involved in the analysis and data collection. So after data collection, the three stages are data transformation, data search and retrieval, and data analysis and exploration. So for each of these goals, we have created outputs. So for data collection, I will be introducing the hypothesis extension of custom tags. For data transformation, Cody will be showing you the terminology, the ontology that we developed to go from the structured data to a systematically organized analyzable data. And then for data search and retrieval, we will present a mobility query service based on a knowledge graph. And lastly, for data analysis, Cody will present Rail Finder, showing different connections, sort of deep connections between the different nodes involved in the data. So as I said, the focus for my presentation will be on data collection through the text annotation platform. So to take a step back, why we chose to make this process more efficient. So as Marcus introduced, for the CBCM project, they are covering a long period, starting from 2000, gathering company data from transaction notices. And there's no central database for these transaction notices, so these have to be manually gathered from the registration, from the national registrations. And on the screen, you can see a screenshot from the report representing period from 2006 to 2019, indicating how many incoming and outgoing transactions were in these countries. Moreover, there are different types of transactions. So these further complicate the issue of analysis of the notices. So there was a big why of doing so. And there were certain processes put in place at the CBCM project that we wanted to further develop. So the aims of data collection were to indicate, firstly, the most basic information in transaction notices, such as registration numbers, dates, countries, but also dig further and to find information about the employment numbers that could indicate certain rights violations or other aspects that may be related to tax evasion or other financial system abuses. For the 32 countries covered, we looked at the different registrations, the national registrars that are, of course, in the different national languages. So that's one of the complications. They also come in different formats. In the formats, and also we connected. So Pedro and the IDS team connected that to Orbis. To provide some automated inputs to the system. So we want to go from this unstructured data in the different languages to a structured data in a CSV file. So to provide information in a consistent manner for all these countries, for all these transactions, to keep track, to analyze, and to also view the trends in this area. There are different approaches you can take to data collection. Of course, certain things can be automatically extracted, but a lot of the information have to be manually extracted from the transaction notices. So you can see the transaction notice is, it can be a PDF file. It can also just be published as a web page that has to be read manually. In our case, we had law student assistants helping us. It could also be lawyers or someone with expertise in company law. And the first approach taken in the project was to collect this data through Google Forms. So that meant that student assistants would have to read the original file and then go to the form to enter this information, either through a drop-down menu or through typing out this information. So when we assessed the efficiency of this system, we found that there were some inconsistencies. For example, the company form could be entered in a different way. So for human reader, we see that these s.arl or s.arl, we understand that these mean the same company forms, whereas for the machine readable way, these are read as separate entries, and that causes issue in further analyzing this data. We also found that it creates, Google Forms would create time inefficiencies, as you would have to go from the original document to the Google form. And of course, with manual entries, there are risks of typos or rephrasing the original text in some ways. That is, again, introducing inconsistencies in data later on. So what we'd like to propose is to collect the data through directly annotating the text in the original document. Again, this can be a web page or a PDF file. So the advantages of this approach is that you annotate directly in the document and you collect the data as it has been written by the original authors. You can also provide a direct reference that gives you context about the data collected. And lastly, it is also very useful for later on using the extracted data as annotated training data for machine learning and natural language processing algorithms to further automate this process in the future. So for NWA project outputs, for data collection specifically, there are two main outputs. We developed the hypothesis custom tags extension. So this was mainly done by Cody and Alex on the project. And the second output is annotation guidelines. So setting up the annotation system, instructions that will be given for the annotators to enter this information. And this job was mostly done by myself and the student assistant Tobias. And we also worked with the law student assistants who were already working on the CBCM project. So it was great to work with someone who has the experience of using the old system And they have the training as well to test out the new system and whether it provides a comparable results. So to provide a little bit of background, what is Hypothesis? So the Hypothesis is a free and open source text annotation software. It is available as a Chrome browser plugin. And it focuses on annotating the web and PDF documents. If you go to their website, you can see that some of the examples include biomedical data or data in biology. So they focus on creating these crowdsourced annotation projects. The big advantage of using this program is that you can annotate data exactly where it is, rather than having to extract it and put it in your own system, which can be very time consuming and introduce some inconsistencies. So the idea for this project was to take this open source software and improve it to adjust it for our purposes to provide further functionalities that could be useful for legal text annotation. So as an overview, Hypothesis extension can add annotations. The added features that you can see highlighted in green is that you can also upload and use custom tags and tooltips. So based on your annotation guidelines, you can directly upload that as drop-down menu. So you would only enter the annotations that you need for your project. Existing features also included collaborative setup through private groups, so creating your own projects, so you can supervise your annotators and double check the agreement levels among them, as well as the public annotation feature allows for crowdsourcing projects, as I mentioned, that are more common in hard sciences, such as biomedical domain. Lastly, we added a new feature of extracting the data for machine learning purposes. So here I'm providing an interface overview of Hypothesis custom tags. So you can see, again, if you go on Hypothesis website, you can already log on and try it out if you want, but I'm just going to guide you through the features that are available. So the main feature that we've added is that you can import custom annotation panel, and you can do that as a CSV file. You have the annotation panel where you can see the name of the annotator, the text that has been annotated, the tag that you're adding, and you can also leave notes so the annotators can communicate among themselves, as well as they can make some comment if certain information is missing or it is possibly inconsistent with other documents. So you can provide additional information on top of the label that you've used. To zoom in on the annotation platform and maybe how you can use it. So you can see in the sample, we have the user Cody Mutley. Underneath that, you can see that he's part of the NWA annotations group. As I mentioned, you can set up different annotation groups. The annotation itself happens through highlighting text in the original text. So while you're reading the text, you're finding the information that is needed, you highlight it and add the tags that are automatically extracted for analysis in the pipeline. And then for the import tags, this is something that would be individual for each of the projects. So you have to consider what sort of information you want to extract and create your guidelines that you can then summarize in a CSV file, providing the tag name, the definition, and possibly a tooltip. So in other words, a tooltip is the information you would find if you hover over a text. So if the definition is very short and you want to provide further examples, you can do that through the tooltip find. Moreover, in the custom tag features, we've added color coding that could be helpful for the annotators. For example, if you want to emphasize that certain annotations must be entered, you can choose them to be grouped in a certain way under a specific color. So these are small user-friendly features that we have added to the original hypothesis tool. And here, if you go to the section of the groups on hypothesis website, you can see that you can create several different projects. There's no limitation. And if your project requires double annotation for certain aspects, so you want to compare whether the same information is entered by two independent annotators, you can set separate groups where they can't see each other's annotations, and then you can extract the information and compare the inter-annotator agreement as well. So this is more maybe for the legal researchers and empirical researchers in the audience, but that is another really nice feature. So that was a presentation of the hypothesis extension. And in the second part, I'd like to talk a little bit about annotation guidelines. So if you have chosen to set up a text annotation project, that later you can use this information to build the knowledge graph or linked data, as Cody will show in the next presentation. These are some things to keep in mind. So first of all, you must know your data. Ideally, there are several domain experts on the team, so definitions of the terms can be agreed on and possibly standardized, because it's also very important to look for existing guidelines. So if there are terminologies available, if there are ontologies available in your area, it's always better to reuse and extend existing things so they can be compatible for later being linked and providing a richer database. Other things to keep in mind is to think of what type of information you're interested in. So as I said, for the NWA project, we were mostly looking at the core information that has to be in the transaction notices, such as the date, the company's name, the country, the target country, the acquisition company, and other types of information if we wanted to further extend it. For other research purposes, it might be more interesting to look at certain words or phrases. Let's say if it is a case law project, we might be interested in looking at different types of reasoning in that, and that could also lead to a sentence level. So these things have to be considered before starting the annotation process. And lastly, if there are any agreed definitions, for instance, Eurovoc is a vocabulary of European law terms, it is always a good starting point to look at something that's already been reused and agreed upon in this area. Then the second part you should consider when setting up your project is who will be your annotators. So what is their level of expertise? Is your team composed of lawyers, legal researchers, law students, or possibly the task could also be crowdsourced from general public? And then there have to be assigned also task supervisors just to make sure that the accuracy and consistency is maintained throughout the program. And lastly, of course, training. So I do believe that with legal texts, there's almost always some training needed compared to some other annotation tasks you might seen, which is maybe distinguishing different photos of whether there's an animal in certain photo. When we talked about legal text annotation, complexity is a lot higher. So the training and guidelines are very essential. And why, another why for a reason for needing annotations is the consistency of entering certain information. As I said, in Google Forms, if we add free text, there might be different ways people write the date, the age, or any other type of information. And for machine readable and reusable data, it's important that it is entered in a very consistent manner. And if we take the information from the source text, and if we have already preset these custom tags, such consistency can be ensured. And here, an example of how to convey maybe information for the annotators. It's important to use intuitive tags. So they are as descriptive as possible. You should include a definition and a few examples to show how this information looks in the real life. And then for the tooltip, I said you can give a further tip, a reminder. I would say an experienced annotator would not need a tooltip, but if you have a new team, it is very useful for them to have this reminder. And here's an example of a snippet of the CBCM project guidelines. So you can see at the top, there's a notice, and it's been annotated through hypothesis custom tags information. So all our labels start with CBCM, and then the abbreviations are the ones that are agreed upon in CBCM terminology that Cody will tell you a bit later. And then we give examples from the real text. Again, in CBCM, we have several different source languages. So we also wanted to include examples from different languages. Another thing to keep in mind for your annotation team is the language knowledge, of course. So that also has to be considered. And lastly, I just wanted to show some examples of annotation use cases. So we focused, when we were developing hypothesis extension, we focused on transaction notices, but the extension is not limited to transaction notices only. So we wanted to show a few examples how it can be reused. So here is a little video of transaction notice scenario and how the annotations are added in the text. But the second example I wanted to give is from case law. And this might be interesting for legal researchers, again, for linked data. If there is a case on cross-border mobility and there are certain terms that have been defined in the case and you wish to link that to transaction notices or other data sources, it can also be done. The annotation part can also be done with hypothesis extension. That is it for the annotation presentation. Thank you for your attention. And I think we have some time also for questions before starting next session.
Thank you, Ruta. We can take some questions now about the annotation section. I know that there's a lot to take in. Possibly, maybe you have a lot of questions about that or want to know a bit more detail. So if you want to ask a question, please feel free to ask it in the chat or use the raise hand feature of Zoom. If you want, you can also just go ahead and unmute and ask a question directly. Okay, it seems, yeah, most of you are kind of all up to speed then on the annotation section. Just to also follow on from what Ruta said, the custom tags extension for hypothesis is available publicly as an extension that you can reuse. We shared the download link in the slides. Am I correct, Ruta?
Yes, I also posted in the chat now.
Yes. So this is a custom tags tool that we used on this project to basically test and evaluate whether this actually improves the way that we currently collect data in the CBCM project. But we also kind of in the evaluation phase of that. So we haven't really fully integrated that into the pipeline yet. But the idea is once it's integrated directly from those text annotations, that information is imported into the knowledge graph. Yeah, so we have, I think, two questions on the screen here. I think it's Marilu and Monica. I don't know who was first, Marcus?
No, it's. I just wanted to add that we also have a question in the chat that I think was only raised to me, which is it was first. So I want to give that person the possibility. Mehmet Bakaren asked a question whether we also use newspaper content. Maybe Ruta or Cody, you can answer that one before we turn to Marilu and Monica in a second.
Yes,
I promise.
so who asked that question?
Yeah, that was Mechtet Bakkeren from the KVK had that.
Okay. Hi, yeah. Yes, that's a very good question. As I will explain in the next session, we have various other sources of information which could be connected, to this knowledge graph, and newspaper articles could indeed be one of them. In fact, I mentioned one example of that with the GDELT database, the Google database of global events, which is along those lines. But yeah, to answer that question, indeed, it could be valuable to enrich our graph. Okay, shall we move on to the other questions by Monica and Marilu?
Yes, I think Marilu, you were first, please.
Thanks. I'm Marilu. I'm a PhD researcher on this project, and it's supervised by Marcus. And I'm working as well with the data, and I'm really excited about this software. I was wondering what you do with inconsistent information. So you connect different sources together, and what happens if things are, well, not compatible? So for instance, this source of information provides this data point, and another source of information provides something differently. So I was wondering, how can you solve these inconsistencies? And sort of a second question, which was not entirely clear to me, is that you, as I understand correctly, you don't need to extract data anymore. But for instance, I'm working and I'm reading as well the transaction plans. They are still coming from somewhere. So I was wondering how this works with plugging in the software on where you store then in the end your data.
Yeah, so I can only answer from more the technical side because I worked on that. But Marcus, feel free to also jump in if you need to. So the way I usually approach this is we try to make a catalog, right? We make a data catalog of all the different types of data that we can possibly collect. So Marcus and myself and Pedro worked on this to see, okay, what are all the pieces of information that we want to collect and we find interesting in the CPCM project, and then categorize them, right? So where do we get them from? So by source, where do we get them from? And also, what vocabulary do we use? A standard term that we use to define each property of, like, let's say the registration number of a company, or the business address of a company, and so on and so forth. And then we build an infrastructure for extracting those pieces of information from the different sources, and then we combine it together to form a central repository of information. And that is then converted into this graph that you see. That's from the technical standpoint. I don't know if Marcus or Ruta want to say something extra about this.
Yeah, maybe then from like the CBCM idea, I did not dwell on that too much in the introduction, but the idea was to collect those transactions. So what we did is we have different sources indeed, where we find information. And as Mehmet asked with a question, you can find information in newspapers also on new transactions, right? There can be a deal announced on for instance, a merger. Since I'm a lawyer, then I would still go into a national registry, because that's legally binding to check whether or not such a transaction is taking place. Indeed, there can be other use cases where you are not so much concerned with, because these transactions that we are showing, we verified them also. So we go through several steps where we are verifying whether such cases have actually taken place, that a company is being deleted from the registry after, for instance, transferring to another country, to make sure that those cases actually took place. With a newspaper article, then from me as a lawyer, that has not so much weight compared to, for instance, a notice in a national registry, but certainly you can tie this information in. Also, data on company core data, how many employees is a company having, such information can be found in different sources. And as Cody said, we pool that in one place and then convert that to the knowledge graph. Cody will I cannot explain that, but also Cody will go into that in a little bit. But important is that you have an idea about your data structure before you start such a project, and that you then follow the steps in a systematic manner, of course, in order to then have an as clean data set as possible. I think it's impossible to have a completely clean data set. You also have missing data. So you were asking, for instance, about the transaction plans. So these are detailed documents that go about the detailed information of a transaction. There's a lot more information to be found, but we only do this for a handful of cases. And then the question is, do you include this in a knowledge graph where you then have a lot of gaps in the data for a lot of the cases, or not? Or you do make subgraphs where you then have only a subgraph on those specific aspects. So there's technical possibilities to gear the data pipeline to your needs. And there was a thought process going into this, and it's also iterative. So we adapt where we find new solutions or better data sources. Then you have to go back to the drawing board and revise your data infrastructure.
Yep, thanks, Marcus. Yeah, so Monica still has her hand raised. Sorry, Monica.
No worries. That's a very technical question. I might have missed that in your presentation, Ruta, but so if I understand correctly, hypothesis can be used also for annotating directly the websites, right? Not only PDFs. Okay, so I mean, from the technical point, so you just kind of read in the list of URLs into hypothesis, and then like each annotator can open a link and annotate it on the web, like in the browser, or how does that look like? So that's one question. And then the other question is, I mean, do you then separately also download these websites to make sure that you have all the data stored somewhere, or how do you do this? Because I mean, websites are changing constantly, right? And you want to make sure that somewhere you do have the full data set, not only the annotations. And if I understand correctly, hypothesis gives you the output only of the annotated snippets, right? So like the question is, how do you kind of manage this part?
Yeah, so I'll start with the annotation, like the practicalities. So the hypothesis extension works as a Google Chrome plugin. So as you said, directly you can send a link to your annotators and they can start annotating on the web. So that should not be an issue. But for the downloading and storing the different versions of the website, I'll pass that to Cody because I think he would know the answer better.
Yeah, so I think that's a very good question. It's something that we considered as well on the project. Luckily, for the most part, in our project, we focus mostly on the PDF documents. So we download them and annotate those. But yes, so hypothesis, the way it works is when you annotate on a website, it's just like how you browse a normal website. When you do some surfing or browsing on the internet, you go to different websites in your browser and you visit it. And now hypothesis is just a little pop-up window on the right where you can say, I need to make a note of this, and I just annotate and I add it there. The annotations are stored in the cloud so that you can access them from anywhere. So I can go to another laptop and I can also access the annotations. I can also share them with other people by sending them a link. But the question there about, let's say a website changes, what happens then? So indeed, the piece of text that you annotate is kept by hypothesis and stored in the cloud. So it never disappears, that piece of text. But if the context around that page has changed, yes, then in that case, it is a limitation of hypothesis in the sense that it doesn't archive or take a snapshot of it, but there are ways to get around that in terms of maybe downloading the website, indeed, like you mentioned, but there's no button in hypothesis to do it for you. You'd have to do this manually. Or alternatively, make use of things like the Wayback Machine on the internet, where you can look at previous versions of pages on the internet. So you can browse and see, that. So there are ways around this, but indeed, it is a very good point that you mentioned, that it's a limitation if you want to annotate web pages specifically. Yeah.
would be cool to add it to hypothesis.
Yes.
Thanks.
Thanks, Monica.
Maybe one very practical point for legal projects, Monica, right, where you would be working with, for instance, student assistants or with colleagues. What's really neat is that if you have a PDF and you are opening that in Chrome and annotating it with Hypothesis, if you are sharing that PDF that you annotated with another person, somehow Hypothesis is assigning a token so that if another person is opening this PDF, your annotations are being shared with that person also. So for the purposes of data traceability, this is a very neat way to make sure that everyone is looking at the same annotations. And yeah, for those legal transactions, since they are anyways legally binding documents, so give a very practical example. If I have a transaction from the Netherlands to, say, Germany, then we are downloading this notice from the Dutch Staatscourant, and we are storing that PDF file. And if I then annotate this and then give this document to another colleague to verify this transaction, this person is seeing then my annotations and what I've done there, and can carry on, for instance, with the verification notice of said transaction. So that's also helpful, maybe.
But maybe as a short follow-up, I mean, but you can also kind of not show your annotations to other annotators. That's also an option. Okay, perfect.
Yes, so I think that's the really nice feature, is that you can either have this collaborative project, or you can set these private groups with the same text, but they don't see each other's annotations. So yeah, if you want two annotators working on the same text without seeing, that's also possible. And then you can supervise both of these groups and participate in those as well.
Yeah, and just to also add on to what you just said, just to also to add on there, we did have a text annotation workshop recently, a couple of months ago, and we recorded that text annotation workshop. It was basically a demo also of this this hypothesis tool in more detail than what you see here in this event. And our plans are to publish that on our website. And you'll see on in one of the earlier slides in this slide deck, there's a link to our website as well. And we plan to share these slides with you as Marcus indicated. So you can also have a look there about more instructions about how to do this kind of annotation. You can also wait until the breakout sessions at the end of today, and you can ask more details about that as well. We're happy to help you with that. Okay, any other questions? I don't see anybody's hand up here. Yeah, so we are running ahead of schedule. So we have 10 minutes ahead. So what do we reckon? Do we want to take a break right now until 2:45? That's quite a long break. Or do we want to come back a bit earlier?
Perhaps we can continue for another 15 minutes or so and then break.
And then break. Okay. Yeah. Yes. Okay. So let me then. What's a good place to break is, then I'll introduce the concept of the knowledge graph, and then we break after that, and then we can continue with the platforms after. Okay. Let's let me share my screen. Okay, so as Ruta mentioned, we developed this tool for streamlining the way we collect this data, so we avoid these inconsistencies. But now we want to import that data in a format that is compatible with knowledge graphs. And I'll explain to you now a little bit about how we constructed this graph. And okay, first of all, what knowledge graphs are for those who are unfamiliar with the term. And then we'll break, and then I'll explain how we queried and analyzed this graph after the break. I see we had another question in the chat from K55 MTB. How did you collect company data of all EU countries? yeah, I guess we can, do you want to take that question now, Marcus, maybe?
Yeah, maybe really briefly. So
Yeah.
the way it works is that these transactions concern public notices and companies that are being registered in the various EU member states. And annual accounts of these companies are publicly available. And as mentioned briefly by Ruta in the presentation before this, we have access to Orbis, which is a company database on 270 million companies worldwide. That data set is not complete, but it gives us access for research purposes on a significant amount of companies. And we collect then data on the sector that a company is operating in. The NACE code, which is the European standardized classifier for what this company is engaged in. Is it a holding company? Is it an operative company, etc., as well as employee core data of said company. And we try to verify this as much as possible also, as I said, through annual accounts and the like, so publicly available documents of companies. I must add that data access in the European Union is not unified, and it is quite a struggle for certain jurisdictions to obtain this information. And it can also be quite costly endeavor. So to give you an example, annual accounts are for free if you, for instance, download them from the Luxembourgian registry, but they cost 10 euros if you download them from the French registry. So there are significant differences between EU member states with regard to data access for a research project. I'm always talking about for scientific purposes and not for commercial purposes. So only for scientific purposes there are ways to access the data, but it's still quite cumbersome from time to time. I hope that answers Mechtel's question.
Thanks, Marcus. Is it okay, Marcus, to also maybe mention how large roughly this information is, what this database is?
Yeah, of course. So we have in the European Union, we are not discussing the CBCM project at length here, but there's also ample data available, open source available on the CBCM project. I'm happy to share that information also when we are circulating the slides later on. We have about 15,000 transactions collected thus far for the time frame 2000 to 2020. 2021 is ongoing. And out of these 15,000 cases, about half is cross-border mergers. Then we have about 3,500, don't quote me on this, but about 3,500 cross-border seat transfers, about 3,500 European companies being registered in the European Union. And then we have 31 cross-border divisions. I can give the exact number there because cross-border divisions are very rare cases. So yeah, there's a significant data set, but it's still manageable and compared to mergers and acquisitions. I don't want to go too much into legal details, but a cross-border merger or division or seat transfer is a universal transfer of assets and liabilities, which is not an M&A transaction where you buy assets of another company. So that would be a share transaction. We are not covering that in this project. We are only covering legal mergers, which means that, or legal cross-border conversions or divisions where you have a legal transaction between those two companies, and it concerns about 15,000 companies.
Okay, thanks, Marcus. Let's move on then to the next section here. So in this part, I'm just going to explain very briefly. There's a lot of detail that we're going to leave out for obvious reasons, for time constraints and so on. But we can take more questions, detailed questions about this in the breakout sessions. It's about how we transform this data that we collected into a knowledge graph, and explaining also what a knowledge graph is. So maybe that's what I'll start with, and then we'll break, and then we can continue with the session. So for constructing the graph, the main question is that we have to decide is how do we actually represent this cross-border company mobility data as a knowledge graph, right? And then obviously the question here, the initial question is, okay, what is a knowledge graph? It's a huge buzzword that's going around. What actually is it, right? Well, a knowledge graph, one definition for it, let's say, is just a way to represent information as a set of nodes, which you see here, these little circles on the screen, and relations between them, right? Which we call entities and relationships. Right, so here you have a graph about some people and the locations they've visited all around the world, and some artworks like the Mona Lisa and so on. And they're all connected in some way, and they represent rich information about those connections. So the nice thing about knowledge graphs, one of the benefits is when you actually represent data in this format, it becomes very easy to link to other data sources. Right, so for example, here we have a small graph about a travel. It contains entities like the Eiffel Tower and Alice and Bill who visited the Eiffel Tower and Paris and so on. And we can actually ask this graph, right? This graph has enough information in it for us to ask, okay, who visited the Eiffel Tower, right? So it's able to answer that question. It has the content in order to do that. But let's say we have a much more, a little more complex question, right? Who are the friends of those who visited the Eiffel Tower? If we add another graph, like a social network, let's say, to this graph, to this network, we just need to find a connection, right? So we need to find some entity in the initial graph and a relationship between an entity from the new graph and that graph. And then we've connected the two. And now we can ask increasingly more complex questions. Similarly, if I add some information about geolocations, the locations of objects. Here, in this case, the Louvre Museum, which is also located in Paris. I can now ask the graph, is the Louvre located in the same city as the Eiffel Tower? And this graph should be able to answer that, or at least software which is able to query a knowledge graph will be able to answer this question for me. And similarly, it can become even more complex if I add more and more information. And this is the value that this representation format gives of a knowledge graph. So if I add a graph here about art history, I can then ask this more complicated question: which friends of those people who visited the Eiffel Tower are interested in artworks that are exhibited in the Louvre, right? So that's, in a nutshell, is what the concept of a knowledge graph is. I think this is a good place to stop. I think we're on time just about, right? 2:30 for a break. So if anybody has one or two questions about this knowledge graph format, I can take them now. Otherwise, we can just take a break until 2:45. I see Marilu has her hand up. Go ahead.
It's maybe a difficult or a question, but it's a knowledge graph. So things we know, right? It's about facts. What is it? Also a bit more fluid information. So, for instance, catch me if you can. If you want to ask, for instance, the question: is this transaction done with bad intentions? To put it very bluntly, that is a legal question, which is always very. It depends, or depends on how you see it. Are these softer questions? Are these also answerable by using a knowledge graph? Because knowledge is, facts.
Well, so you raise a good question. Is that okay? These are more complex and questions, and they have a legal aspect to them, right? Which is not, so black and white. The idea here is that the way researchers currently answer these questions, they need to access to data, right? They need to look at data, formulate some, hypothesis about what's going on here, and then write a legal interpretation of it or whatever. But the way they have to do it right now is they have to look at the raw data, and they have to learn how to analyze it. They have to learn all these data science techniques and so on, which takes a lot of time, years and years to learn, in order to do these kind of analysis, to first find answers to simple questions so that you can work on the more complex questions in a more efficient way. And so this project is trying to develop research tools or platforms to answer these more simple questions so that you can gather evidence, right? So I'm going to ask a simple question here, a simple question there about this company, that company, and then gather it all together. And then it's up to you to tackle the more complex questions as lawyers or policymakers or so on.
I would also want to add something as a way of explanation. Yes, indeed, the knowledge graphs are extremely useful in flagging suspicious transactions. And I will give you a very clear example. Let's say we discover a merger between two companies. One of them has two owners that are previous financial offenders. It is a fact, it becomes part of the knowledge graph, and the red flag can be carried on. Now, in the academic medium and in the business medium, we cannot take ourselves legal actions, but what we can do is exactly this, to flag and issue a report to the state authorities, such as the Intelligence Financial Unit or the police or whoever, and they can further analyze and take the legal decision, go to the prosecutors. So indeed, it's very useful because many informations are in the system, fake transactions, fake companies, offshore companies that have legal problems and so on. But at this moment in Europe, they are not yet connected. And this knowledge graphs comes to connect this data.
Yes, thanks, Diana, for that. That also adds to it. Yeah, that's one of the challenges, right? Is how do we connect all these different data sources? And the infrastructure is not there yet, right? In the EU for harmonizing and connecting all these things. Everything is all disjointed and all over the place, and makes our life harder as researchers to put it all together. But the good news that we're trying to show here is that the technology is available once you do that to really provide these tools to make researchers and policymakers' lives so much easier, and save so much time actually to do the research. Okay, yeah, so we can take a break now if there's no further questions until 2:45, and then we'll continue with this section, and we'll explain, we'll give some examples of how to do this kind of analysis, right, and answer these simple questions. Thank you. Thank you. Thanks, Marcus. Right, so we're going to continue now with session 2 on constructing the knowledge graph and also querying and analyzing it. Just before the break, I mentioned the concept of a knowledge graph, right? And it can be sort of construed that this is a new concept or something that we created, but in fact, no. So this is the concept of a knowledge graph, has a rich history in academia already for many, many decades. But it has gained in popularity, let's say, in the last 2 to 3 years or so. And in fact, the knowledge graph that we constructed in this project is not the only example, obviously, of a knowledge graph. There's knowledge graphs in industry and academia, representing different types of information, from biology to law to various other topics, even general knowledge graphs as well. So in this domain, let's say, of corporate mobility, there are even other knowledge graphs loosely within this. So for example, the Panama Papers data set, which many of you might be familiar with, which is a large-scale leak of around 11.5 million documents, legal documents and financial documents, revealing some information about politicians and organizations that try to hide their cash from the tax authorities and so on. So this data set, which has been released now publicly, has been also represented as a knowledge graph, and there are efforts to further enrich this database. And one of the goals or ambitions of our project is also to link this with our graph to see if there are any potential overlaps information that can be used to enrich our graph as well. There's also the Gedelt project, which is a Google project, which is to stream or extract all the world's news articles in different languages from different countries, and convert this into machine readable format. And this is kind of following on from one of the questions that we received earlier about whether we want to extract information from news articles as well. Indeed, this would be an example of one of those data sets. And the nice thing is it's gone and done the work of extracting those articles for us. And it's one of the ambitions of the project is also to integrate this kind of information. And that will help us look at, what are the influencing factors maybe in cross-border company mobility. By looking at certain events that happened, we could find triggers, potential triggers for certain behavior, right, by companies in the EU. Okay, so how did we construct our graph? Well, the first thing, as I mentioned earlier, was to figure out, to make a catalog of what kind of information we want to represent, what kind of information do we collect, and the critical thing to make it machine readable, right? And that's the key thing here with this knowledge graph that we're building, is we want to make it machine readable so that our software is allowed to process this and reason with it and so on. We need to make a standardized vocabulary for all the terms that we use in this graph. So there was no existing standardized vocabulary for representing specific terms related to cross-border company mobility in the EU and EU company law in general. So our team took up the challenge and we created our own vocabulary. And you can see a snapshot of this here. This was in collaboration together with Marcus and Ruta and Thomas Biermeier as well. So it's called this EU CBCM ontology. Ontology is just a fancy word for a vocabulary which is machine readable. And this was the base for us now to make a catalog of these terms, and then later on we can use this to convert the data into to use these terms to refer to them in the graph. So this is a very high-level diagram of what we did. We went from a traditional database spreadsheet format where the data is represented in this tabular format, which is familiar to those of you who worked with relational databases. But then we had to make a catalog of, okay, what are going to be the nodes in this graph? What are going to be the relations? What are going to be the attributes of these nodes, right? And we decided, okay, so we're going to have nodes for companies, for transactions, company transactions, so mergers, divisions, acquisitions, and so on. The countries involved, the shareholders involved, right? The owners and so on of companies. Relations between them. So is a transaction having a merging and an acquiring company? And does the company also have a parent company, or is it a subsidiary company of another company? So these kind of relations. And then attributes, right? So the addresses, the employee figures of the company and so on. And you can see this little symbol here with the gears is kind of like the magic here, which is the software, which is using technologies to convert from the relational database format into this graph format. And that's what our team worked really hard to do. And we managed to accomplish this in the project. For more details about it, if you are inclined to learn more technical details about that, we'll be happy to answer your questions in the breakout sessions at the end of the program. Okay, so how did we, after constructing this graph, how did we actually query and analyze it, right? So we created 2 prototype tools, and the key word is prototype. So these are still works in progress, and we're hoping to also get feedback from the community and whoever wants to use these tools, what they'd like to see and be included in the tools, what additional functionalities and so on. So these tools are for searching and exploring the knowledge graph. And I alluded to this earlier, that they help us answer questions, research questions about what's going on in this graph, what's happening with these company mobility actors. and companies and so on. The first research tool that we developed is this data search and retrieval tool called the EU Corporate Mobility Query Service. And the intention behind that is to actually be able to, you can ask this query service some questions. Please fetch me all the cross-border mergers that satisfy this criteria between these countries and so on, and it will give it back to you. So then you can have a look at that, you can analyze that and make further decisions. So if you go into this platform is actually based on this technology or suite of technologies, which we call Wikibase. And Wikibase is a very popular project, and it's actually used to power, and it's kind of the engine of Wikidata. Wikidata is a knowledge graph again, but this is about general knowledge, just like what information you'd find on Wikipedia. Wikidata is kind of converting that information that you find in Wikipedia, but to a structured machine readable format, so that computers are able to process, query, analyze, and reason with this information and answer questions about it. So that's Wikidata. And Wikidata is powered by the suite of technologies called Wikibase, and we reuse this in this project, this Wikibase technologies, and we'll cover that later in this session. So this is a screenshot here of the Wikidata query service, which Wikibase provides. And I'll just quickly circle here for you so that you can see what's going on. So this section here, which you see, is actually the section where you supply a query, where you ask a question to the graph, right, to this knowledge graph. In this case, Wikidata is about general knowledge information, so we can ask about films to do with Tom Cruise, right? So here, this query is basically asking, I'm finding all those entities in your graph, which are instances of the category film. So they're all the films in your graph, and where those films have the cast member Tom Cruise, right? So once you run that query, you will get the results which you see at the bottom here. So the list of the films where Tom Cruise is the cast member. And you can see that this additional functionality of this filtering process allows you to easily do that without having to know particular data science skills or technical ways to analyze knowledge graphs. Another nice feature about Wikidata and Wikibase technologies in general is that if you create a knowledge graph, you can also, for each entity in that graph, you can have a web page, and you can decide whether it's publicly available or not as well. You can have a login and so on, where you can go and look up that information and you can see structured facts about that entity. So in this case here, if I go to the movie Top Gun on Wikidata, it has this page which has structured information about it. We have the different languages in which this film can be represented, a description about this, this film here. We have that it's an instance of a film. It has the title Top Gun. It has even a topic, military aviation, and it has a genre, right? It's an action film. And if you click on each term of vocabulary as well, because Wikidata also has its own ontology of vocabulary, it also tells you what those vocabulary means, right? So what is a title? Okay, it's a published name of a work such as a newspaper article, etc., etc. So it makes it easy to interpret what's going on, right? So often we share our data with others and we don't really know what's going on here, and we need to find out what's going on, and we need to ask a lot of questions and back and forth and so on. So this way of representing information is rich in the sense that it tells you what you're looking at as well. That not only the data is here, but how to interpret the data is also here. One-stop place for finding all that information out. Okay. So what we did with the EU Corporate Mobility Query Service is we also adapted these Wikibase technologies to use for our knowledge graph as well. So we imported this graph into Wikibase technologies, and it allows us now to also ask queries that are interesting for us in cross-border company mobility. For example, give me all the cross-border mergers where the source country of the merger is from Germany. And then you get a list of results like this, which are links to the pages like you saw for Top Gun previously. It also has a visualizer where you can look at or visualize the results, right? The nodes that are returned here in your results section. And additionally, we also have those pages, just like you saw for Top Gun. We can also now go to a specific cross-border merger and the page for it, and we can see, okay, the target country for this cross-border merger was the Netherlands, and the source country was United Kingdom. So in other words, this company or this transaction means that some companies are moving from United Kingdom to Netherlands. And the transaction date was that, and the employment figure for the merging company in this transaction was 14, and so on. And again, you also have the vocabulary is browsable as well, so you can see what each term means as well, so you can interpret that information. If I share it with you, and if you're not from the domain of cross-border company mobility, you can still make sense of it. Right, so to show an example, right, of how we can use the platform, let's take this example of observing trends about corporate mobility. A researcher may ask, or a policymaker may ask, okay, have the number of incoming company mergers increased or decreased from one year to another in a specific country? And if we look at a specific example, maybe let's look at the Netherlands. Have the number of inbound company mergers into the Netherlands increased between 2018 and 2019, right? So have the number of companies that are being acquired into Netherlands increased, right? In between these 2 years. So I have a screen recording here to show you that on the platform, how we would do that. And I'll just share that. Hopefully you can see this, and this is legible for you, the text. But you can see here, there's a filter section, and I'm going to add a filter now. So I'm searching for all cross-border mergers because that's what we're interested in. So I just type it in here, and there's this autocomplete feature to find that information. So I'm going to pause it quickly. I search for cross-border merger, and it pre-fills the property as instance of. So I'm looking for all those entities which are instance of cross-border merger. If you want to change that property from instance of to another property, you just click on the drop down here to pick another property. But in this case, it suits us fine that it guessed that we want instance of. So we'll go ahead with it. Okay, but what else do I want? I want to make sure that these mergers come from the Netherlands specifically, right? So then I add that property here as well. So I type in the Netherlands, and I make sure that it's the source country is not what I want. I want the Netherlands to be the target country, right? So incoming. So I have to change this by clicking on the drop down, as you'll see if I play this forward. So I search for target country and I find it, and I just click on it, and now it's done, right? So this will give me all the cross-border mergers coming into the Netherlands. Here it's limiting to 100 results in case you don't want to wait very long for an answer. If you have a huge database, you can limit the number of results just to see. But in this case, I'll remove it, as you can see, by removing it there. And then I run the query by clicking on that big play button. And you'll see in the bottom right hand of screen, there's 446 transactions, right? Where the target country is Netherlands. But now I want to check specifically for 2018 and 2019, right? So in this case, on the left-hand side, there are no filters currently in the feature set for filtering for date. So what we do is we use this query language on the right-hand side, which is called Sparkle, which helps us filter more fine-grained. But in the future, we hope to also add additional features sets here where you can filter for dates as well. But right now it's still possible, but you'd need to know a little bit more about this query language here, which you'll see on the right-hand side. So I checked for cross-border mergers where the target country is Netherlands, and I want to make sure that this cross-border merger, I'm going to get the transaction completion date. And this is the way I do that. And then I create a variable for the date, and then I want to filter that date. So I add a filter here where the year of that date is equal to 2018, right? And then I run this. And you'll see in the bottom right-hand side, there's 23 results, right? So there's 23 transactions in 2018 coming into the Netherlands. Just as a disclaimer, it may, so these results, when we recorded this, may not be updated with the full database. So that may not be accurate with the full database, but it's just to give an impression of how to use the tool, right? So if you run this on the full data set, you may get different results. Okay, so then we changed the 2018 to 2019 to get the 2019 figure, and you get 26 results. So we got our answer here that there's 3 extra transactions, right, between 2018 and 2019. Yeah, so that's how we might do that to answer that question. Oops. So now let's move on to another example, example 2. And this is a slightly more, well, quite a lot more complex in the sense that, okay, we want to see the impact about how real world events affect corporate mobility. In this case, Brexit, right? So how did that affect the number of companies which left the UK, right? So how many companies left the UK by cross-border mergers in that period from 2018 to 2020, which is around the time, 2018 was around the time Brexit came into force. And as compared to 2015 to 2018, so just before Brexit, right, the years leading up to Brexit. So we can do it like this. So again, I will play a video here for you. So similar process, we use the filters on the left here. And I'm searching again for cross-border mergers, as you'll see, right? I'm looking for all those cross-border mergers where the United Kingdom is the target country. No, sorry, that should be the source country, right? So we should change that. Yeah, hopefully, yeah, okay, I do, yeah. Source country is United Kingdom. Remove the limit, we want to see all the results. And we get 375 results there. But now we want to filter for date. Again, we can't do this on the left yet, so we do it on the right. We add the filters on the right. So first I need to get the date of the cross-border merger. So I use this autocomplete feature to find transaction completion date, and I click it. And that transaction completion date has some sort of date, which we call question mark date. And then we filter that question mark. So we say, okay, I'm only interested in those dates which are after or the same as 2018. Let's say, I think it's 1st of January, 2018. Right. And what comes afterwards, it's just the telling the system that this is a date inside these quotes. And then it's before 2020. So this date must be after 2018, the 1st of January 2018, but it must be before the 31st of December 2020. So there's 2 filters here to give the date range. And then I run it, right? And I get 89 results. So there's 89 companies which fled the United Kingdom after Brexit. But now we need to just change those dates to see what happened before, just before, right? So just 2015 to 2018. Right? And we run the query again, and we immediately get the results 7, right? So you can see the huge jump, right? Only 7 transactions in the 3 years leading up to Brexit, but in the 2 years after Brexit, like an extra 82 companies, right? So you can see the impact there. And you can see there's just a few clicks and a few seconds, whereas, you know, if you had to wade through the raw data and look at database tables and so on, this may take a whole lot more time, right? Maybe a day's worth of work or a few hours worth of work, which you can do now with a few seconds. Okay, so that's that. Oops, sorry. Let's move on to the next slide here. Now we'll move on to the data analysis and exploration platform, right? So that was for search and retrieval, which we showed you, the EU Corporate Mobility Query Service. But then there's also a tool which we developed to help us analyze and explore connections in the graph. And it's called the EU Corporate Mobility Rel Finder tool here, which you see a picture of. And the concept of this is based around this idea, right? So you see this image on the screen. Those of you might be familiar with this from, you know, watching crime movies or crime TV shows. It's a crime board. It's a board which investigators use to connect pieces of evidence in a case and try to find out what are the interesting connections here and how to solve this case, right? So what pieces of information help us decide who is the culprit. So it's based on this concept. And this is a screenshot of what it looks like currently. So you have here a section for selecting the entities. Currently, we are searching between 2 entities. It allows you to search between 2 entities. To find the paths, right? In the knowledge graph, you can see the knowledge graph has a lot of nodes and edges between them. So it's trying to find a path, a connection. Can I walk from this node to the other node in the graph? And what do those paths look like? What kind of relationships does Germany and Finland have in the graph, for example, in this case? And then you have here a graph control section where you can, if you press refresh graph, it will search for those connections, just resets everything back to normal so you can start over your search. You can also decide how far am I looking between 2 nodes? So how many jumps, how many links, right? You can look for maximum distance 2, 3, 4, and 5, and 6. But so the key here, why would you want to vary this is, well, if you have the more distances you look at, the longer you have to wait, right, for a result. So maybe you're in a hurry and you just want to see any short connections between these 2 nodes, then you'd select 1 or 2 links, right? Edge labels here just allows you to check, to decide whether you want to show the names of the relations, right? The relations here. Right now, you see it's not enabled, so you don't see the names of the properties, but you can also just flip that here to see the labels as well. And the legend for showing you like what are the different types of nodes here. So if it has an icon like this, it's a company. If it's like this, it's a company transaction. It's like this, it's a person, and so on. The entities that you are trying to find connections between are colored in purple, in this case, Finland and Germany. And the selected entity that you click on is in red. So I clicked on this cross-border merger here, for example. That's what it looks like. It also, if you click on a specific entity, it shows you some useful information, attributes about that entity. So in this case, this cross-border merger has some acquiring company employees. There are 3 employees in the acquiring company. And these are the number of employees in the merging companies, I think, diverging employment figure. I think Marcus will be better equipped to interpret these figures for me. But anyway, this is useful for those who are you're familiar with this kind of data. Okay, so now let's have a look at an example of how we can use this platform to potentially find connections that we're interested in, right? Or to use it as a research tool to explore the graph. So let's say I know of a person in my graph, John Smith. And let's say we know currently that he was found to be guilty of some financial behavior, financial crime, tax evasion, or some sort of thing like that. Let's say he's found guilty, right? And we know this to be a fact. Then if I look at my graph, I can possibly also look at connections that John has with other people or other entities in the graph, right? Let's say he's connected to another person, Ann Wilson, then perhaps it could be interesting for an investigator to investigate Anne as well, right? Because she has some connection to him in the graph. You know, perhaps we find that Anne is a global ultimate owner of a corporate structure, and John owns a subsidiary company within it. Or maybe Anne and John are shareholders in the same company, and this will be visible in the connections in the graph. And then this can possibly lead, if Anne is guilty, also found guilty as well after the investigation, then it will help us, find that. So here's an example of how we do that on the platform. So I have a screen recording here as well. I find two entities here, Henk and Rinke, right? So I want to find some connection between them in the graph, right? So let's see if there are any connections. I make the maximum distance 5, I refresh the graph, and then the graph appears, right? It finds all the paths between those nodes in the network. And then you can see if I scroll up a little bit, hopefully here. Yes, I do. Okay, good. Right, so in this graph, what we have is we have Rinkhevelen here, right? So the first entity, remember they are purple. So that's the first entity, and then we have Henk over here in the graph. And we see that actually Henk owns two companies, Loopring BV and Porter Credit Insurance BV, right? So he or she or whoever this is owns these two companies. And then these two cross-border mergers here, 1 and 2, where they're both the merging companies of these cross-border mergers. And the acquiring companies for both those mergers is the same company. It's Hernandez and Wilcox BV. So in other words, Hernandez and Wilcox is acquiring both these companies, right? But then we see that this company has a parent company. So it's a subsidiary company of another company called Zamora. And that is owned by Rink. So we can see that's the connection here between Henk and Rinke. This may or may not be, shady behavior, lack of a better term, but it just shows you the functionality of the tool here that we're trying to highlight. We can spot these connections, and it can spur further kinds of hypotheses about what's going on here with these companies. Okay, so that's one example where we have persons. What about if we just want to focus on companies here, right? So let's say, do company A and company B have any shareholders or stakeholders in common, right? We may want to explore that. So we could have a similar kind of use case here, where I search for hopefully two companies here at some point. Yeah, so in this section here again, you will see that hopefully, yeah, okay, there, yeah. I'm searching for a first company, M2 Property Invest Limited. and I am looking for another company, let's say, I think it's wind services or something like that. Yes. Then I find the second company, and then I search for the connections between them, right? So refresh, and I find this graph, right? So I find that, okay, so both these companies are involved in these two cross-border mergers here, but critically, I see that I find this person, Mr. Placharski, who seems to own both of these companies. So that can be interesting, right? To find out, okay, there's some commonality here in the corporate structure, the shareholder structure of these different companies. And that could help investigators, pinpoint what's going on and who's responsible for different things. Okay, so I think that's fairly straightforward. We can take some questions afterwards if needed. Just to summarize now before we move on. So what we've done here is we've constructed this knowledge graph of corporate mobility, and we've also constructed different tools and platforms to be used in different stages of the project. So for data collection, we have the hypothesis tags for collecting this information in a consistent manner. Data transformation, we created a machine readable community vocabulary for corporate mobility in the EU using semantic web technologies. And we also created these two platforms for search and retrieval and data analysis. So that's the Wikibase, the EU Corporate Mobility Query Service, and the RelFinder tool, which I just demonstrated now. There were a lot of challenges in the project here, some of them that we struggle with. So the data consistency and completeness and quality of the data was an issue, ongoing issue. The team had to spend a lot of time, cleaning data and processing data and so on. The text annotation guidelines that we developed still need to be demonstrated to the annotators, and the annotators need to be trained in using these guidelines to collect the information. And the platforms themselves, right? So these are prototypes, and we want to build and extend on these functionalities. And we are aware that it requires, for example, for Wikibase to do the filtering for the dates, you need to know some technical query language, which is not that difficult if you spend a little bit of time on it. But it's we could foresee, for example, having a feature there to do that automatically, just like you could with the previous filters. And lastly, we also want to evaluate these technologies because they have to be used by people in the end, right? So people who don't necessarily have a background in software engineering and so on, and so they need to be trained in using these platforms. What we want to do in the future is link to other knowledge graphs that we find online. For example, the Panama Papers knowledge graph, the Gedelt database of news and information sources, and socioeconomic knowledge graphs as well. Like, for example, the World Bank knowledge graph, which stores socioeconomic information from different countries. So we can analyze, what are the underlying influences in corporate mobility? What is the kind of the triggers here for this phenomenon? We also want to find connections in RelFinder amongst more than two entities. Right now, we only look at two entities. Maybe there are multi entities we want to look at. So we want to find connections between 3 or 4 entities, right? Is there something connecting all these 4 people? And that's something which is on the horizon as well. And we want to use advanced graph analysis algorithms, clustering to find groups or cartels of companies or people and so on. And we want to use the data that we generate from the text annotation to train natural language processing models to automatically identify corporate mobility information from legal documents. In particular, we applied natural language processing for some countries to find entities and information from there, but there's some limitations in it. In particular, recognizing company names in text is extremely difficult that we find. And perhaps those who are interested in NLP might be willing to assist us with that as well, if you're interested in working on the project. Right, so I'm going to hand over now quickly to Pedro Hernandez, who is our data engineer on the project. And he's been working together with Marcus to try to make our knowledge graph findable, accessible, interoperable, and reusable, in keeping with these principles of scientific data management. And the key here to recognize is that although the nature of this data is sensitive, so it's not publicly available information per se, FAIR does not mean that your data should be open. FAIR is about making descriptions of your data. So being able to find a description, a high-level description that, okay, this data exists, it was collected on this date, and it's by so-and-so. The data itself doesn't need to be published and made available if the organization doesn't choose to do this, but certainly this description of the data and how to get access to it at all, if it can be accessed, that protocol for accessing it can be available. So I'll hand over to Pedro to tell us what they've done on this front so far in the project. Pedro.
Yes, thank you very much, Cody. Yeah, I mean, I wanted to very quickly share with you all how are we doing with the data management of this research. So, I mean, first of all, in order to ensure good open science and modern open science, it is at the end of the day recommended to follow these FAIR principles to manage your research data, right? It's like a recipe to manage all the scientific information produced in the project. This recipe is one out of many, but I mean, this recipe came up together given that there were like 100 recipes and no one in the world was communicating. So people sat together and say, okay, we need one central principles so that all the scientific community we agreed upon, and that was the paper 5-6 years ago, right? So let's call this information that was produced by the research digital objects. And you can see on your left-hand side, the digital objects are the metadata, that is basically the information about the data, meaning the when and how or who generated the annotations, for example. So you have also the data, which are the annotations and the documents themselves. You have the software, so all these processes and all the pipelines and all the software development that we generated. And of course, the publications and reports, right? So according to FAIR, a digital object have to be findable. Okay, can you press? Cody, yes. Next, yeah, has to be findable, meaning that yeah, they should be indexable on search engines. Long story short, if you Google it, or if you Google it on research data, you should be able to find the metadata descriptions at least. It should be accessible. Another click. Yes, so that, for example, the metadata in this case and the publications are open. Open source literally means that it's royalty free, but that's not the case for the data, for the annotations of the software, just like Cody described. In our case, we want, or the protocol to access this is that it is open only for research purposes, and an application to it is required. Again, FAIR does not mean open, but transparent of how you deal with your scientific information. This digital object needs to be interoperable, so that, and yeah, basically these files can be accessed with non-proprietary software from anywhere in the world, and they should be reusable. So, for example, you should mention the terms of use of your data, in this case, open license, for example, or a tailored license, or a license that you need a token to it. All these things should need to be mentioned. So we have color-coded to more or less map the status of the data management. We have color-coded. Green are the things that we have already implemented. Yellow kind of work in progress, and red, we are not yet implemented. So I guess we're doing okay. So if you have any more questions about the data management and about the data also, yeah, let me know. Yeah, that was it.
Thank you very much, Pedro. We're just, almost at 3:30, so we have time for maybe 1 or 2 questions before we close for the break. So please go ahead and either paste your question in the chat or raise your hand using the raise hand feature, or just unmute and just go ahead and ask your question. Okay, I think it was kind of, okay, so we have another question from Marilu. Hi, Marilu.
Yeah, hi, thanks. I was wondering how difficult it is up to now to find information on, you provided the links, for instance, the shareholder of a company. And I know up till now, things are not publicly available. And in the Netherlands, they want to make a register for that, which is not open, of course. But how difficult is it, or was it already to map these relations, especially with regard to shareholders?
So from the data perspective, I think Marcus is better equipped to answer that. So Marcus.
Yeah, that's probably one of the most tricky things to access. Already the question in the earlier session this afternoon, there was a question from Mechthild, if I'm not mistaken, with regard to the data. And we use Orbis as well as annual accounts and the like to access data. For micro companies, data is often not available. That means that in a lot of cases, when it comes to cross-border conversions, seed transfers, those companies are micro companies in an overwhelming amount of cases. And due to that, there is no reporting requirement of these companies, which leads then to the fact that no data is available in these semi-public databases that we can access through, for research purposes. That means that if there is no data available, then we cannot index it, and then we cannot search it eventually then in the project here. For bigger companies, and especially in cross-border merger cases, this often concerns intra-group restructuring. So about 95 to 99% of those transactions are intra-group. Those are fairly large companies, and that means that data quality is much better for these cases. For the purposes of states wanting to analyze these, you already referred yourself to the UBO, to the ultimate beneficial owner registry that the Netherlands has not implemented. I mean, we are based in the Netherlands, and this is unfortunately the case. Up to now, the Netherlands is not very transparent or not transparent at this point when it comes to this. That's certainly something that needs to be addressed, but then on a legislative level. And I think that's something for the breakout session which Ruta and I will be hosting, that we can delve into. What do we want from the European and the national legislators in order to create a framework so that us researchers can do our work? Because if there is no data available, then we cannot do this at the end of the day. And I think that's also a question then for the panel discussion in a moment as well. So I don't want to delve too much into this to not steal the thunder of our panel also. But yeah, you're certainly having their point. But so far, for larger companies, we have the information. We could already collect upwards from 1 million data points on this data set of 15,000 cases that I referred to earlier. We have over 1 million data points. So that shows you that there is a richness of data, but the smaller the company, the fewer data there are. And when it comes to ultimate beneficial owners, that's particularly problematic for certain jurisdictions in the EU at this point.
Okay, thanks, Marcus. Thanks, Marilu. So we have a break now until 3:40, where we will have a panel discussion with our 3 distinguished speakers. So yeah, we will yeah, let's reconvene here again at 3:40 for that. Thanks.